Hello students, welcome to the third video of the chapter Trigonometric Functions. In this video, we are going to learn a bit about the graphs of trigonometric functions. Graphs of trigonometric functions. You must have heard that a picture says 1,000 words. So even after remembering so many formulae and doing so many questions, if you remember the basic flow or basic format or behavior of the graph of a particular trigonometric ratio, you can solve hundreds of basic questions which are often being asked in MCQs form. So this is a very conceptual topic. See, the last thing was algebraic. Once you just remember formula, you can know how to solve the question. And this topic is very, very conceptual. So earlier you had learned, in class 10, you had learned only about acute angles. That means 0 to 90 degree. But now you should know what is the overall behavior of first three. I'm dealing with only three trigonometric ratios here. Rest of the three we will do in detail in classes. The first trigonometric ratio is y is equal to sine x. Right? Now this is a function. We had learned about functions in chapter 2. You can go back and watch those videos. Sine x is a function. So you must first of all know what kind of function it is. Is it one-to-one function? Is it many-one function? So all these things are basically related. Getting conceptually clear about one thing actually removes all the doubts whether it is in functions. Later on you will be learning about inverse trigonometric functions, and these are trigonometric functions. So see, you should know in what kind of graph will you get, but before that you should know what is the behavior of sine x, right? Sine x is a many-one function. Why many-one? I'm going to tell you everything. It is a many-one function. It is a cyclic function. It is a cyclic function. Cyclic or periodic function. Periodic function. It is an odd function. See, all these things have their values when we come to put the values and use it. It is an odd function, right? Now, what is many function? Why do we call it a many function? Because you must have learned this in functions chapter also when you had done this types of functions. Sin x is a periodic function. Let me draw this graph first to explain you a few things. I will try to make it as clear as possible. This is, let's say, pi by 4. This is pi by 2. Pi by 4, pi by 2, 3 pi by 2, 2 pi, 5 pi by 2, then 3 pi. Right? I'm not going beyond it. Minus pi by 4, minus pi by 2. You know what is minus pi by 2? The domain and range of this function. What is the domain? See, this is the x-axis I have taken. The whole x-axis we can go to extreme left, that is to minus infinity, and to extreme right, that is to plus infinity. That means the domain of the function is, domain is R. R means the whole number line from minus infinity to infinity, you can take the values of x. Domain is the values of x. Range is the values of y, right? Domain of sin x is r. You can go as negative as you can go as positive as you can. What is the range of this function? Range of this function is, you remember this, it is always between -1 and 1. These things you have to remember. When you learn about functions, just stick to all these basic things. You will never forget the behavior of the graph. Range means what are the possible values of y? This is the interval from -1 to 1. That's why I just plotted -1 and 1. You can go cyclically to infinity on both the sides, but graph cannot go beyond +1 on the upper hand and -1 on the lower end. So let's start plotting this. If you have, you remember, you need to make a table of this and then remember those values. I'm telling you and drawing those things. Pi by 4 is pi by 2. Sine pi by 2 is 1. So just put dot. Opposite to pi by 2, we have sine pi by 2. Sine 90 is 1. Sine, this is pi. Pi by 2. This is pi. This is, sorry. I'm sorry. Okay, this is pi. And this is 3 pi by 2. Right. See, this is 0 to pi by 2. This is 1. Sine pi is 0. Sine 3 pi by 2 is sine. Just give it a graph, like, see. Now this 1, right? This is 1 by root 2. Sine pi by 4 is 1 by root 2. Sine pi by 2 is 1. Sine pi is 0. So when it goes to this like this and then it comes back to 0. Then sine 3 pi by 2 is -1. -1, right? Come here. And then sine 2 pi is 0. Make it like this. This is one complete cycle of sine, right? On the positive end. Now see, if you draw it on the negative side, this is also, I'm sorry, I have a wrong value. Minus pi by 2. If I plot it here, right? Okay, this is minus pi. So 0 minus pi by 2 is -1, right? Then it goes to pi here, which is 0. Then it again goes back to this value. So if I extend this graph to this type, right? It is a cycle, one complete cycle of 2 pi radians. See, what is a cyclic order? Cyclic order is a periodic function. Cyclic or periodic function is a function which repeats itself in the same manner after that complete period. Now, what is the period of sine x? Right? Period of sine x is 2 pi. All these things have to be remembered. Domain is this, range is this. That means you can go extremely to left, extremely to right. And in case of y, range, you cannot go beyond whatever, even you can convert the angle. Like if you have sine 3x, still it will never go less than -1, more than 1. Whatever sine x is, it can be 4x, 100x, 2x, because see, angle is this way. This is 1 pi, 2 pi, 3 pi, 8 pi, 100 pi. So you can go up to infinity pi, right? On negative side or positive side. But the value remains between -1 and 1. That means, I'm just making it here so that you understand. See, it can be extended to this value. It will be giving like the same cycle on both the ends up to infinity. But this one cycle is 2 pi. The second 2 pi cycle starts from here. This is 2 pi, then again 2 pi, then 2 pi. After every cycle of 2 pi, sine x, the values of sine will repeat, right? Like if you have angle of sine 720, right? What is 720? 720 is a multiple of 360. 2 pi is what? 360 degrees. So 720 will exactly have the same value, which is because after every 2 pi value, you will get the exact same value with same sign, not even positive, negative, right? So this way you can see that this is the cyclic behavior, odd function. You will learn this. This is an odd function. Sign of, how do we decide whether a function is even or odd? It is sine of negative x is minus sine x. That means if you replace x by minus x, the value of the whole function becomes opposite. Such functions are odd functions. Sine and tan are odd functions. And cos is an even function, right? So let's say we come to the graph of cos x. Here also let me write the basic things. Domain is R. The range is still minus 1 to 1. Minus 1. Here the value will be a little bit different, but range is still 1 to 1. And periodic function. It is a periodic function of period. Period 2 pi. Right? Anything else? And this is an even function. Even function means it is cos of minus x is cos x. That means even if, see, even an odd, like f of x is x square. So if we write f of minus x, it still remains the same value. That means this is an even function. Like x square is an even function, similarly cos x is an even function. And if we have fx is x cubed, so what will be f of minus x? It will be minus. Here, if we replace x by minus x, the whole function sign got changed. This is an odd function. Similarly, sin x and tan x are odd functions. If we substitute x by minus x, the value of the whole function gets reversed. Sine and tan are odd functions. Cos is an even function. So I have written all those things. Odd function, many one. Okay, this is also many one function, right? Why it is many one? Now let me explain this concept too. Many one means, see, for this value pi by 2, we have 1. For this value, we have 1. So for multiple values, see, all these values are x. Here, x's are different. Values of x is different. But y, you are getting same y. I have told you in the function also, like when we have minus 1 related to 1, 1 related to 1, multiple values of x giving the same value of y. It is many one function, right? So I have written all the characteristics of cos x here. Now let me plot the graph. I'll try to take values nearby so that, see, but here you have to make a table. This is pi by 2. This is pi, 3 pi by 2. I will be making only larger divisions. This is 2 pi. This is 1. This is minus 1. Right? Now, if you start with cos 0, cos 0 is 1. Remember here, sine 0 is 0. So I started with 0 from here, and sine 90 is 1, so I took it to 1. In this case, cos 0 is 1, so you have to start from here. When x is 0, y is 1. Cos pi by 2 is 0. So just link this thing to this. Right? Cos pi is minus 1. Now go further below. Right? Cos 3 pi by 2 is 0. See, you have to remember basic things. Odd multiples of cos, odd multiples of cos, 0. Value is 0. Pi by 2, 3 pi by 2, 5 pi by 2. Odd multiples of pi by 2, the value of function of cos becomes 0. Cos 2 pi is again 1. 3 pi by 2 is again 0. 3 pi is minus 1 and then again 0. This way you can complete the cycle to infinity, right? So cos minus pi by 2 is again 0. This is minus 1. This is 0. Then again 1, 0, and this way, right? So the shape of this is sin x. I had plotted it on a broader scale, so it was difficult to this. Otherwise, the shape is exactly same. The period is exactly same. This is 2 pi period, right? Here also the period is 2 pi, but the starting point here is from 0 is 1. Here it was 0. The cycle started with x0, y0, and then at 2 pi it again became 0. Here we started with 0 with 1, and cos 2 pi again ends up to 1. Then again the cycle starts and go tilting. So this is the behavior of cos. Domain and range are same. This also cannot go beyond -1 and more than +1. This is an even function and period is again 2 pi, right? The last graph we are going to do is very interesting. It is tan x, right? So y is tan x. Now this is, you can say this is a periodic function, but not continuous. See, things are very interesting. You will be learning about continuity here. This is a non-stop graph. That is why it is a continuous graph. Now tan x is a periodic function with period pi, not 2 pi. Period is pi. Domain is R. Range. What is range here? Okay, we'll plot the graph and then I will tell you. Pi, and this is an odd function. And obviously this is also one kind of function, right? See. Plotting this graph is actually needs practice. But remembering the graph actually helps you while solving the questions. So just invest some time and learning this. You will be very comfortable in trigonometry. This is pi by 2. This is pi. 3 pi by 2. 2 pi. Right. Minus pi by 2. Now tan 0 is 0. I need to wait. Why I am doing this? You will see here now. On pi by 2's, odd multiples of pi by 2's, just draw these dotted lines. Now tan 0 is 0. What is tan pi by 2? Tan pi by 2 is sin pi by 2 divided by cos pi by 2, sin 90 upon cos 90. Sin 90 is 1, cos 90 is 0. So what happens? Tan 90 becomes 1 by 0. What is 1 by 0? 1 by 0 is not defined. That means when denominator approaches to 0, the fraction approaches to infinity. So tan pi by 4 is 1. See, if I plot here pi by 4, it is, let's say here we have 1. Here we have minus 1. So tan pi by 4 is 1. But as we come to pi by 2, this shoots, sorry, you cannot touch this here. You shoot this graph to this point. Infinity pe shoot, right? Now this is again negative of, like this is sin pi by 2 is minus 1. Right, sin tan minus 90. This is minus 1 by 0. So it goes to negative infinity. this way, right? Here also pi by 2, 3 pi by 2, it shoots to positive infinity. Here it shoots to this. Please don't touch this line. And here also, this way you have to complete this graph. So this is the behavior. See, it is a cycle of, this is a discontinuous graph. Why? Because at all the multiples of pi by 2, the graph is getting disconnected. It is not a continuous chain. So this is not continuous, but it is periodic because the behavior is same in every period of pi. This is a period of pi. This is repeated here. After every pi period, the graph is getting repeated in the same shape. That is why it is called a periodic function. But the period is pi. Domain is R. You can extend this graph to the left of infinity to the right of infinity. Right? And range. What is range now? It is minus infinity to plus infinity. You can have extreme values. It can go up to plus infinity. It can go to minus infinity. Right? So this was the behavior of trigonometric graphs of basic three trigonometric identities. Not much has been already explained in these graphs. I hope you liked watching this video. So if you want classes or you have any query, please do contact me through my profile on Apple. Thank you so much.